All right, diving in today, and we're looking at interaction diagrams, in software engineering, how those different parts of a system, all the pieces, how they all come together to actually make things work. And you found some really interesting stuff on this, right?
Yeah, it's like peeking behind the curtain, seeing how all the components in a software system are chatting it up, sending messages back and forth to get the job done.
And there are a bunch of different ways to visualize these conversations happening, but we're going to zero in on one specific type, the sequence diagram.
Right.
Think of it like a timeline, like showing the order in which these conversations are actually taking place. So today, really our mission is to understand, what are sequence diagrams all about? Why are they so important? And how do we actually go about building one?
I think a good place to start is with the broader category. So interaction diagrams in general,
Okay.
they basically show us, how objects in a system are communicating.
Right.
So not just what objects are there, but the relationships between them and the messages that they exchange. And the big idea is to understand how a group of these objects, how they collaborate to achieve some specific, piece of functionality.
Hmm.
Often it's tied to a use case, right? So some specific task that the system has got to do.
Okay, so it's like seeing that collaboration in action. And I know the stuff you sent mentioned two main types of these diagrams, sequence diagrams and communication diagrams. But like we said, we're going deep on sequence diagrams today. What makes them so useful?
Well, I think the really cool thing about sequence diagrams is that they really highlight the time ordering of these messages.
Right.
You see step by step who's interacting with whom and in what exact order.
Okay.
The basic structure is that you have your participating objects, and they're laid out horizontally like a ground the pop.
Uh-huh.
And then as you read down the diagram, it's like time is flowing, right?
Yeah.
And you see the sequence of these interactions.
Yeah.
So it's like a really clear chronological view of what's going on.
It's like watching a play unfold, right? Each object having their own little part.
Exactly.
So when we look at one of these diagrams, what are the core elements that we're going to find?
So you always start with a frame around the whole interaction. And usually that frame will be labeled with SD, which stands for sequence diagram, followed by the name of the diagram. And then within that, you'll see the actors.
Okay.
And actors are basically entities outside the system that are either sending or receiving messages.
Right.
So these could be, users, other systems, even hardware components. They're really representing those roles that are interacting with the system.
Okay, got it. So those are the external players. What about inside the software itself?
So inside, you have objects,
Yeah.
and those are usually shown as rectangles with their name. And sometimes you might see the class name included as well. It's like,
Okay.
object name, class name. And each of these objects has a lifeline, which is a vertical dotted line that represents its existence, during that particular interaction.
Mm.
When that object is actually, active and doing something, like processing a message, you'll see a solid vertical bar on the lifeline. It's called an activation bar.
Oh, okay.
So think of the lifeline as its potential to act, and the activation bar is when it's actually doing something.
Makes sense. And then the actual communication, that happens through messages, right?
Yeah.
And I saw there are a bunch of different types.
Yeah, and understanding the different types of messages is really, really helpful. So you have synchronous messages, which are shown with a filled arrowhead.
Okay.
And with a synchronous message, the sender sends the message, and then it waits for a response
Gotcha.
before it does anything else.
Okay.
And this is important to understand because, if you have a lot of synchronous calls in a really critical path,
Hmm.
you might end up with performance bottlenecks.
Yeah, makes sense.
And the sequence diagram makes those potential issues really clear.
Yeah.
Then you have asynchronous messages, which are shown with an open arrowhead. And there, the sender, it just sends the message, doesn't wait for a reply, and can keep on doing other things.
Right, right.
And then there are return messages, which are usually a dashed line with an open arrowhead. And that just shows the response to a synchronous call.
Oh, okay, okay. What about things like, creating an object or deleting one? How are those represented?
So for that, you have specific messages. You have a create message, which is a dotted arrow labeled create. And that shows when a new object is, being instantiated. And then there's a delete message, which is usually a dashed line that ends in a little destroy symbol.
Gotcha.
And that indicates when an object's no longer needed. Although it's important to note that in systems that use garbage collection, that doesn't necessarily mean it's immediately removed.
Oh, right,
It
right.
just means it's like ready to be collected
Yeah.
whenever the garbage collector gets around to it.
Int-
And then there are also some less common scenarios like lost messages where you know a message was sent, but you don't know if it was received. Or found messages where an object receives a message, but you don't really know where it came from.
It's interesting. So it's like, imagine you're sending a notification to another service, right?
Exactly.
But you have no confirmation that it arrived. That would be a lost message.
Right.
Or conversely, you have this component and suddenly it's getting a request, but it's not really clear where it originated.
Exactly.
That's a found message.
Exactly. And then finally, you have self-calls, which happen when an object calls one of its own methods. And that's usually shown as a nested activation bar on the lifeline.
Oh, okay. So that's a pretty comprehensive set of communication types. Now, I know the stuff we looked at also talked about stereotypes.
Yeah.
What role did they play in these diagrams?
So stereotypes are really helpful because they clarify the roles that classes or objects play within the system. And there are three key stereotypes that you'll often see. You have boundary objects, entity objects, and control objects.
Okay.
So boundary objects typically handle the interaction between the system and the outside world. So think of, UI screens or APIs, things like that. And usually there's at least one boundary object involved in each interaction between an actor and a use case.
Okay.
Then you have entity objects, and they represent like the core information and data within the application's domain. So things like, customer accounts or product details.
Okay.
And finally, you have control objects, which manage the overall flow of a particular use case.
Oh.
They kind of coordinate the actions of the other objects. And typically you'll find at least one control object per use case.
Okay. So they basically help you categorize what all these different objects are responsible for. How do you go about figuring out which stereotype to assign to an object?
Well, the sources suggest looking at the purpose of the object, in relation to those use cases. So entity objects, you usually identify them by the data they manage. Boundary objects are kind of your points of interaction with the actors. And then control objects, they're really the ones that are embodying the business logic and workflow of the use case itself. And often the stereotype will actually be indicated right there in the sequence diagram.
Okay, so that really clarifies how these diagrams work. We've got the timeline aspect, we've got the objects and their lifelines, the different kinds of messages flowing between them, and then how stereotypes help define the roles of those objects. So, big picture, what have we learned from this whole deep dive into sequence diagrams?
Well, I think we've uncovered a really powerful technique for understanding how a software system behaves.
Right.
Not just statically, but dynamically.
Yeah.
Like how things actually happen over time.
Yeah.
By visualizing those interactions, you can really understand how all the different parts of the system are working together to achieve specific goals.
Makes a lot of sense.
And that can be incredibly helpful for all sorts of things like, debugging complex interactions, identifying those potential performance bottlenecks we talked about, even just as a communication tool for development teams.
Makes you wonder, if thinking in this way about sequences of interactions could be useful for understanding other types of systems too, even outside of software.
Yeah.
Like maybe the steps involved in a scientific experiment or how communication flows within a project team.
Right.
Something to think about. Anyway, thanks for taking this deep dive into sequence diagrams with us. It's been fascinating.
My pleasure.
Until next time.